Alright guys, welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today we'll be reviewing some problems for our Chapter 12 test, which again, it will be next Tuesday, alright? So this is your homework. I'll probably do number 2, 3, and 6, okay? So I'm going to do it live for you guys on this recording. So let's start with number 2 here. The total area of a cube is 294 inches squared. Keep in mind, total area is the same as surface area. Okay, so don't get too confused by that. Okay, I have a cube. Okay, I'm gonna draw a cube real quick. It's probably gonna help us out. Oh, let's try to make it look boom. And boom. Okay, decent cube, right? Could be worse, could be better. So for a cube, you know that all faces are squares. Okay, so that's going to help you out. So really, if you think about it, each of these edges, each of these lengths, they're the same unit, right? X and X. So really for the surface area, there's two ways you can do it. The shortcut way is just knowing that you have 6 faces, right? You have 6 of them. What's the area of one face? X squared. Boom. So once you have that, surface area is 294. 294 equals 6x squared divided by 6. Boom, boom. You should get 49 equals x squared. X equals 7 inches, which is the length of one of the edges. Boom, that's it. That's the shortcut way. Let's talk about like the normal formula way, which isn't wrong either. It kind of just breaks it down because we know the formula for surface area is perimeter of the base times height plus 2 times the base area. Okay. So again, it's the longer way, but it's still right. Okay, so perimeter of the base. We know the base is a square. Okay, so the perimeter will be 4x, right? I think we can agree with that. The height would just be x, right? The height is still just x plus 2 times the base area. The base area is x squared. When you work this out, you actually will end up getting 6x squared still. Okay, so whichever way you do it, whether this way, where you're kind of like dissecting the formula, right? Or you do it conceptually. It's more conceptually, right? You have a visual and you map out your plan that way. Okay, they both work out. Okay, that's number 2. Número 3. Okay, hexagonal prism has a base edge of 6. Okay, let's kind of draw a little hexagon here. Boom, boom. Oh, let's get it one try. Dang it. Try this one more time. Bam, bam, boom, boom, boom. All right, I'm gonna try this time, guys. Oh, yes, thank you. Okay, so this whole base edge is 6. Okay, we know that. And the height, okay, this is the height of the prism. Okay, anytime it just says height, it will be the height of the prism. Okay, so that's your H. Okay, that's your H. Now, we know when we're dealing with these type of figures, you need to draw this triangle here. Okay. The throwback, we need to find the central angle. Okay, to find your central angle, it is 360 divided by how many sides? This has 6 sides, so what will that be? 60, ooh, convenient. Okay, so the side is 60, this whole thing is 60 degrees. That means if I cut it in half, remember the purpose of this is to cut it in half. Because now you officially have a right triangle. So if I cut it in half, that means half of it would be 30 degrees. So now all I need to focus on here is this right triangle. We now know this would be 3 because it's half of 6, right? That's 3. We know this is 30 degrees, and this has to be 60. And we want to find that upon them, right? Because we want to find, what's our goal here? Oh, sorry, to find the volume. Volume equals base area times height. Okay, easy. We already had the height. We need to find the base area. So the base area for a hexagonal prism is 1/2 apothem times perimeter. So we need to solve for this A here. To do that, we have our 30, 60, 90. Don't forget your ratio. Hopefully you have a tattoo of it already. So we have the 30, so that's 3. And we can easily just plug that into the others. Boom. So your A, which is opposite to 60, is 3 radical 3. And we simply just plug that in, 1/2, 3 radical 3. What's the perimeter? Or the perimeter is the distance around whatever object. In this case, the perimeter is 36. Okay, 6 times 6, 36. Boom, boom. Simplify. 3 times 18, 36, 64. Nope, 54. 54 radical 3. And then we simply just plug that in. 54 radical 3 times, what's my height? 10 radical 3. Ooh, 54 times 10, that is 540. Radical 3 times radical 3 would be 3. Voila. Beautiful, eh? That would be your answer. Okay, boom, next one, numero 6. Okay, remember, feel free to pause it, 2 times speed, 2 times slower, whatever you need for your own pacing. Number 6, if the radius of a cone is doubled, radius is doubled, and the height is multiplied by 4. Whoa, so the height is multiplied by 4. I'll probably do this. Radius is doubled, okay? What happens to the volume? Okay, so we're gonna start off with the basic foundation. What is the volume of a cone? 1/3, right, base area times height. But we know the base area is a circle. Okay, this is our foundation, okay? We wanna see what's gonna happen to our, I'll say this is like volume 1, the basic one. This is volume 2, okay? So what's gonna happen here? 1/3 pi, what happens to our radius? Our radius is doubled now. So it's doubled squared times what happens to our height? 4h, okay? So let's work this out here. 1/3 pi times 4r squared times 4h. Okay, so let's see, how much did the volume get bigger? Okay, we know 4 times 4 here, that's gonna be 16, okay? So what I'm gonna do here, I'm gonna do 1/3 pi times 16 r squared times h. Okay, I'm just simplifying. But right now what I wanna do, I wanna factor out this 16 just to make it look cleaner. We wanna keep the original here. So I'm gonna factor out the 16. And the original formula for volume stays inside. Pi r squared h. So as you can see, this volume here compared to this, right? Those two are the same. But what happens to volume then? It gets 16 times bigger. Boom. Okay, that's how you do that problem. Okay. Essentially, whatever it tells you to do, 2r, right? The radius is doubled and the height is 4 times bigger. You plug those into your new volume formula. And once you plug those in, you then compare your new volume to the original formula. And you can see that it got 16 times bigger. Okay? All right. I'm gonna do a bonus problem next. Okay, so please check the next video.